So now we'll be looking into our first example. The question asks us to find the area enclosed by the curve y equals x plus 2. At the x-axis, the lines x equals 1 and x equals 3. So it is always better for us to plot the graph. So this is our x-axis and this is our y-axis, and this will be our y equals x plus 2. So it will have y-intercept at 2 and x-intercept at negative 2. Because for y-intercept, you'll substitute x equals to 0, so you'll get 2. For x-intercept, you'll substitute y equals to 0, and then you will get x equals negative 2. Okay. So then the question states that the other two boundaries will be x equals 1 and x equals 3. So x equals 1, and x equals 3. So now I will be highlighting our boundaries. So our boundaries will be at y equals x plus 2. So y equals x plus 2. The x-axis, so this will be our x-axis. The lines x equals 1 and x equals 3. So now I've highlighted the boundaries. So just like what you have seen, we could see that this area over here has its borders highlighted. It means that this is the area enclosed by the curve, the x-axis, the lines x equals 1 and x equals 3. So that is the area that we want to find. So recall our formula for area. Area of region bounded by the curve and the x-axis, we would need to take the interval from a to b, and we'll take the upper function. So in this case, our upper function is y equals x plus 2. So the upper function here is y equals x plus 2, and our lower function will be y equals 0, because we are at the x-axis. So because the lower function is the x-axis, and therefore y is equals to 0, because we are at the x-axis. And again, I repeat, our upper function will be y equals x plus 2. So upper function minus lower function. And then you will need to integrate the whole thing with respect to x. So you'll write dx. So our interval would be from 1 to 3. So our a would be 1 and our b would be 3. And our function, as we have already said just now, is x plus 2. Because y equals x plus 2 is on top of the x-axis. So our upper function is y equals x plus 2, and our lower function is y equals 0. Just to make it clearer, I'll be writing minus 0. And the whole thing will integrate with respect to x. So put dx. So we further simplify to get x plus 2 dx. Okay. So I'm pretty sure that this definite integral would be easy for you to solve. So if we were to solve it, we'll get x to the power of 2 over 2 plus 2x. And this will be from 3 to 1. Okay. So now we would substitute the values. 3 squared 2 and so the first bracket will give us 21 over 2, and the second bracket will give us 5 over 2, and we minus both brackets, we'll get 8. And remember to always write the unit, which is unit squared, because we're finding the area. So that is how you solve questions like this. Okay, so now we are going to look into example number 2. So the question asks us to find the area enclosed by the curve y equals minus x to the power of 2 plus 4 and the x-axis. So first, to start solving, I'll be sketching my graph first. So your y equals minus x to the power of 2 plus 4 will look like this. So this is our graph y equals minus x to the power of 2 plus 4. Okay, so this will be 4. So this is your y-intercept and this is your x. Okay, so to find the y-intercept, we substitute x is equals to 0. So we substitute 0 into x. So now what we want to find is the values of these points here. So how are we going to find the values of this point here? So as you can see, and if you recall what you have learned already, so to find these values here, you need to substitute y is equals to 0 because you want to find the x-intercept. So when you substitute y is equals to 0, so you get 0 is equals to minus x squared plus 4. Okay, then 0 is equals to x squared minus 4. So you get 0 is equals to x plus 2 and also x minus 2. So this is actually finding the roots. So x is equals to 2 and x is equals to minus 2. So this will be negative 2 and this will be 2. So now you already have the values. Okay, so the question states that we need to find the area enclosed by the curve and the x-axis. So let me just highlight. So this is the curve, okay, and this is the x-axis. So where is the area enclosed? So the area enclosed is the area in between. So the area that I am shading right now. So that is the area which you need to find. So how do we go about finding this area right here? So what you need to do is you need to recall the formula to find the area of a region bounded by the curve and the x-axis. So area is equals to, okay, the intervals a, b. So this will be the upper function minus the lower function. So you have to always remember this. Okay, upper function minus the lower function. Okay, and you integrate it with respect to x. So what is your upper function? So your upper function is the curve function right here. So what is the curve function right here? So it is negative x squared plus 4. So negative x squared plus 4. Okay, and then you would need to minus the lower function. So what is your lower function? Your lower function is this. So this is y is equals to 0. So this is y is equals to 0. And you are going to integrate it in the interval negative 2 and also 2. So negative 2, 2. So you're going to integrate it with respect to x. And so you have this definite integral. You can rewrite it. And so you have 2 negative 2 minus x squared plus 4 dx. Okay, so the integral that we have right here is easy for you to simplify, easy for you to find the answer. So when you integrate this, you'll get negative x to the power of 3 over 3 plus 4x negative 2, 2. So you substitute in, you'll get negative 2 to the power of 3 Okay, so the first bracket you'll be getting 16 over 3 minus the second bracket you'll get minus 16 over 3. So minus meets minus, you'll get plus. So you add them up together, you'll get 32 over 3. So 32 over 3 unit squared, because we are currently finding the area enclosed by the curve, so it has to be unit squared. So this is how you solve question like this. Okay, so we're going to continue with example number 3.